Hi guys, Mr. Pollock Biology here. It's coming up to exam time, so I figured probably good practice for you people doing the new AS specification will be to go through some past papers. You've probably seen some of the specimen materials, but this paper is specimen materials set 2, which means that pretty much it's top secret, unless your teachers are very generous, but this is the one that only teachers have access to. So this is teacher only. Everything else you can get off AQA, but this is the one that's probably might be used by your teachers to give you a mock exam. So this is quite useful for you guys. I mean, it's up to you how you use it. If you want to use it honestly to do past paper practice or get ahead in your mocks, I don't know. It's up to you. Depends how honest you are, I guess. But I think there's really no purpose holding back specimen materials from students, especially when we've got such a limited amount for this new spec. So I hope you guys find this useful. I'm going to go through it question by question. Everything that I tell you is pretty much straight off the mark scheme, so I hope I'm able to explain it well enough for you guys. But if you are, struggling a little bit, do put a question in the comments, and I'll do my best to respond to you guys. So let's get stuck in with a nice straightforward question to begin with. Paper 1 is pretty much just factual recall, not too much application questions in there. But we're going to launch in with a bit of DNA. So we're told that the genetic code is degenerate and non-overlapping, and it asks us to define these things. So let's have a little look. Degenerate, very, very nice as a start-off definition. All it means is that more than one triplet of bases is going to code for each amino acid. Okay, so we've got a bit of more than one way to code for certain amino acids. So let's go for more than one triplet for each amino acid. So there's not only one way of getting a particular amino acid. Amino acid. Sorry about my handwriting. I hope you'll deal with it. Next up, why is it described as non-overlapping? Well, because each base in the sequence is only part of one triplet. There's no overlap. It reads it in chunks of 3. That's nice and okay. So each base in genetic code is only part of, how are we going to say it, of one triplet. So this question starts off okay with a bit of factual recall and then a little bit of remembering what the bases are called. So this is really key here. It tells you that this sequence down here is from mRNA, so messenger RNA. And it also tells you the section of the polypeptide for which it codes. So it tells you the amino acid sequence. And the next question is basically, can you remember what the bases are in RNA, which is lovely, a really nice recall question. So we have, of course, A, which is adenine, followed by C, which is cytosine. Then, as in DNA, we've got G, which is guanine, or guanine, depending how you want to pronounce it. And then we don't have thymine, but we have a U instead. We have uracil because we're dealing with RNA here. Now the question flips a little bit, and it says, use the information in Table 1 to give the sequence of bases in DNA that codes for serine. So we've got mRNA, okay? Now, you've got to work out what the complementary DNA would be. So let's look at serine. Here we go. We've got UCA, so all we've got to do is go along and work out what the complementary DNA would be. So U should be T in DNA, and T is complementary to A, so we've got an A there. C is just the same, so C is complementary to G, and A is complementary to T. So our sequence there is going to be A, G, and T. So that, I think, is a really nice question to start a paper off with. A little bit of a twist at the end, but I hope you guys have found that quite useful. And stay tuned, and I will keep bashing through this paper and uploading and uploading and uploading. Take care, guys. Thank you very much. Like, comment, and subscribe.